Hello everybody and welcome to the secret history living in your aquarium. I'm Alex Williamson and I'm here today to talk to you about color, the color of your substrate in your tank. Now, there's a lot of things to consider when you think about color, and it has a huge impact on all the critters and organisms in your tank, from your plants and how much reflected light hits your plants that are the leaves, they curl and turn. Well, those leaves have chlorophyll, and they're going to get light that's reflected off surfaces beyond the light that's shining down on them directly. Likewise, heat is just radiation. It is wavelengths too, and it will be absorbed into different substrates. So what's actually more important about the visible light is the luminosity of your substrate. So you can buy black substrate, think of fluorite or something like that, and it's really shiny like obsidian or something. It almost has a mirror-like finish on it sometimes, and that's going to reflect a lot of light and probably heat too back, whereas a matte black will be much darker. It will absorb those light colors and scatter them so that they don't reflect back out into our eye or to the tank around them. Now, I want to show you guys something that I think is incredible, and I think a lot of people have never taken the time to notice or just haven't had it pointed out, but that is your average aquarium fish. Your quintessential aquarium fish, the neon tetra. Look at their belly. So their belly is a light color, and that's because in the wild, fish, shrimp, plants, all sorts of things have evolved camouflage. And in the case of most small social fish, like the ones in our aquarium hobby, they have a light color on their belly and they have a darker color on their top. Well, this is because predators from below are going to be watching them from below, down at the bottom of the water, and looking up, and the light from the sun is going to be contrasting their body. So they're either going to see a little shadow, and that's the fish target they go after, or they're going to see if they can break up that. If the fish is semi-translucent, like you see with, say, ember tetras, or crystal or glass catfish is a very extreme example, those actually the light goes into, and then the tissue itself refracts the light around and scatters it so that the predators can't actually figure out what's going on. They don't see a clear image to go and attack. Now, from the top, birds and other fish higher up in the water, maybe if they're in the mid-level water, they likewise, usually the fish will have a darker color when you look at them straight down. And in species that we have domesticated, bettas, guppies, gouramis, things like that, that may not be so true anymore. But in the wild, it's something to consider, because you can tell a whole lot about that, because this took millions of years to evolve. Well, before we move on, I want to tell you one more amazing thing about how fish hunt and how they camouflage in their habitat. And that is the fact that fish sparkle. If you've ever seen fish, you know that they're sparkly, that they have this rainbow shimmer, almost like an old CD when you flex it in sunlight and you see the rainbow prism of colors, or a crystal in your window, like a wind chime or something. It's the same exact thing on the cellular level, and that's called iridophores. Now, iridophores are special cells that scatter light, and they may scatter light in only the blue spectrum. So you see a metallic blue, beautiful band that almost seems like it's illuminated from the inside out, because it kind of is. It goes into the cell, light bounces around, and then it comes back out, even if it's entering at a very steep angle. And that's because these cells, these iridophores, are filled with very basic building blocks, guanine and guarine, and they form crystals that are surrounded by a little liquid or kind of goo jelly protoplasm in the cell, and each of those is like a crystal ball that's at a tiny size, and it can also change the profile of a fish. So say that same tetra would normally be a shadow to a fish that's down below getting ready to pounce and hunt and eat it. Well, a lot of actual predatory fish can see ultraviolet light. a lot of predatory birds can as well. Well, when they look and they see a big group of these, one, it's confusing because the colors are reflecting all over the place. So you've got the pigment and the chromatophores or color cells, and that's your basic colors that mix to then look like a color when we're standing back. But you've got your reds, greens, blues, yellows, whites, blacks in nature generally. And then you've got your iridophores, or the how much light is going to reflect off in that sparkly literal white light, or a scattering of any one of the different colors of white light. And what it does is, from below, it takes the light that's reflecting off the bottom of the river or lake, and it totally scatters the shape of the fish. And your fish evolved to know when they're over a surface that is luminous. So even though the light's coming from the top, it's reflecting off the bottom as well. It's also just scattering in the water. And so as you go down in the water, you actually lose color. So in an aquarium, you need to remember that your fish evolved in deeper water. Your fish may be in 20 or 30 feet of water. They may be in 6 inches of water also, depending on the fish. But it's important to remember these things, that when you're trying to replicate a comfortable habitat for your fish, if you have a social community fish, they probably get chased and eaten a lot in the wild, and that's why they are a community fish. That's why they stick together. And even though they're bright and beautiful to show off to one another their colors, usually colors are a sign of, I have a good diet. I'm getting the vitamins and nutrients I need to be the most fit in the bunch. And so that's why you'll see oftentimes too, in a group of fish, you may see that one is colored up more than the others, and that's kind of the dominant one. Or you may see when spawning that they have red all over their belly, or they may totally change color, and it's to show off to other males, don't mess with me, I am king, I've already got dibs on the selection of females in this fish group. Or it might be to the females, hey, come check this guy out. He clearly has a really good diet, and that means he avoided getting eaten. He's fast enough, he's strong enough, and he's got good DNA. And so from a really basic level, that is all going on in a fish's brain. Now, whether it's consciously thought of like that, probably not, obviously. But it's been selected for through evolution, and fish still know if they're in a safe spot. So that's something that I think is totally under talked about in our hobby, is that what does the river bottom look like in the Amazon where your fish live? Is the water so cloudy and murky that it doesn't matter because light's refracting off that murky, dusty, muddy water, and the light is going to be very bright? So though, if in muddy water, even though you can't see very far, when you do see, the light is very bright because it's being bounced around off all those little particles and suspended in the water. And so that's something to think about, is the comfort of your animals and picking something that's going to make them feel as bright or as dim as their habitat. Just like off leaves and botanical material that you can put over your substrate, that's going to make them feel more comfortable if you're talking about rasboras or some tetras or gouramis, things like that, bettas. They are used to living in shallow water, and maybe not in such large groups always, maybe in shoaling species, and they are not used to having to worry about that light breaking up and the shimmering thing that I was talking about earlier. So they are more interested in showing off to the other fish. And so color, even though maybe on their belly and their top is still the light and the dark pattern that you tend to see, the rest of their body may be really bright colors. So that's when we have to think about, what does that signaling say in nature? And what does it say when it's part of your aquarium? So say you want a glowfish aquarium and you want bright neon colors everywhere. Well, that is going to have an impact. One, if you use a black light, that's UV light scattering way differently than in the wild. But two, it is visible light scattering, and it may be showing off reds. And in the wild, red, one, is the first color to be scattered in water. So the deeper you go in water, you lose a color. About every 10 or 20 feet, you lose a different color or tone of color in the water. And so that's something else to think about, is that most our fish in the hobby are going to be living in that actually top 12 feet of water, and it's not so much a concern. But some of the other cichlids and things go a little bit deeper, and they've evolved as such. But red, as I was saying, is a rare color. It is caused by carotenoids or carotenoids, and that pigment is going to be gathered from bugs and bloodworms and maybe fruit or vegetation and tannins and things that they eat off, for instance, biofilms on substrate that's aged in your tank. And sometimes they get it from algae and stuff that we think is unsightly. So that's just another tangent, but we won't get into it here. So when you're picking a color for your aquarium, remember though that red could also set off a female and tell her, oh, there's a male in the water. I should be in more reproductive mode. I'm seeing red. That's a color that's not very common in the wild, in substrates, in river bottoms. Same with, blues, greens, these bright, solid, vivid colors. They've evolved on certain fish to say very certain things, and fish release chemicals into the water. And so when you have a fish, for instance, a guppy also, if they have orange, it means that they took control, both in guppies and bettas. They took control of their little area. They were the fittest male. They were the strongest male. And so they're sporting that they had those carotenoids. Now, it's also part of their immune system, which is a whole other interesting thing. But they choose over their immune system to sport those colors. So that's how important color is to those fish. And if you're talking about shrimp and things, same thing. The shrimp actually have some of the best eyesight in the aquatic kingdom many times. Your mantis shrimp have better eyesight than just about any creature other than maybe some of the falcons and things, hawks and eagles. So beyond the camouflage and trying to replicate, doing the research, figuring out where your fish live, what is the biotope or biotype, obviously you want to decide if you can see them. And that's where the luminosity, or how much your surface reflects light, is the most important. So you can get a matte surface or a dull looking surface, and you could actually still use a dark color, and it's not shiny or shimmery, and so it's not reflecting light back up into the tank onto your plants and onto your fish as much. And maybe you want that. Maybe you want a spotlight look coming down from above. But most people kind of want a bright and colorful tank. And that's why usually using a light colored substrate is better. Now, an aside is the heat in your tank. This is kind of the last big thing we want to talk about, is the retention of heat. So it matters based on a lot more than just what's going on with the color. It's the luminosity, or how reflective it is. Because when you see a color, say you see a blue trash can, you're seeing all the colors that are reflected off of it back to your eye. So it's absorbing every color but blue. So that trash can doesn't necessarily mean it's blue. It's every color but blue, or it's reflecting just the blue off of it, and it's scattering those other colors. Kind of a weird mind trick that goes on, but different predators, different prey, different animals see light different ways, not to mention plants. So if you have plants that you're trying to get the most bang for your buck and you want them to do the most photosynthesis, you want a brighter tank. You don't want a dark substrate that is so dark that it doesn't reflect any light back, and you're not getting kind of an underglow effect from that and on your fish as well. Now, beyond all that, temperature, they've studied from 50 to 80 degrees Fahrenheit. So in aquarium tanks, in kind of home heating range, and they've seen that it can matter up to 23% if you're using light sand versus dark sand. Well, usually dark colors absorb light and heat, and they don't reflect off color, and that's why they're dark. Well, white sand reflects off color, but it also, because it's the properties of sand and the fact that it's actually little prisms a lot of times of silica, it actually refracts light within layers of it. So when you're talking about sand and a few other materials, they're kind of different than stones or little pieces of gravel or fluorite or other things. You could be using marbles or glass beads, because they actually heat up too, and they can make a 23% difference in your heating bill. You can use 23% less energy to get that same temperature, and they're going to retain heat. Sand in general retains heat really well. That's why it burns your feet on a hot day outside. It doesn't take long to heat up. Same with blacktop. It retains heat because it's dark. So first you've got how dark is it, and that gives you some heat retention. Then you've got how much light does it reflect versus does it bounce within itself. And if it bounces within itself and between small little pieces of itself, like in the case of sand, then it can be very hot. White sand can be just as hot as black sand. It can be even hotter. So that's kind of a little hard one as far as judging. But just know, if you're using sand, you're going to be using something that heats up and cools down very quickly. And it will heat up and store that heat somewhat. But your water will store the heat long term after it's radiated off that sand. And it will actually reduce how much you need to heat, compared to using something like a gray stone or fluorite or maybe some sort of aqua soil. One thing to think about. Now, the other thing to think about is just, what is a good tone? I mean, if you want some crazy out there tank that's just really bright, do whatever you want to do, and just be cognizant of the things we've talked about. But if you are trying to replicate nature, look up a biome, a B-I-O-M-E, biome tank, or biotope, B-I-O-T-O-P-E, biotope tank, and you will find all sorts of examples of the rivers where your fish come from. And look up your fish and figure out, what does the bottom of the river look like? Is there algae in the water? Is the water clear? I mean, most people want clear water, but if we're strictly talking about replicating nature, algae, debris, other things in the water are a real impact. But me, personally, I don't want to have a big dusty tank, so I don't go quite that far. But it is something to think about, because in silty water, like I said, the light is much brighter, and those fish have evolved to feel comfortable in that brightness because it's reflecting off of all the particles of the dust and the mud and the silt and all that in the water. Now, the last thing I'm going to say is this is all an aesthetic choice, and the money it saves you on heat may not be the biggest thing in the world, but the stress it can cause your fish is a real issue, and you can have fish actually false charging and flaring at toys and decor and little figurines and things in your tank. So it is important to consider that somewhat, especially with, bettas or cichlids, fish where that matters a lot to them. Beyond that, though, it really is your choice at the end of the day, but remember that there are millions of years of evolution involved here, that they've evolved little crystals that scatter light on their belly to feel safe, and giving them that ambient light from the bottom that scatters rather than from the top where they're a stark silhouette and a target, that makes a difference. It makes them come out in your tank. It makes them more social. And it can make a big difference in how your fish behave, how they are stress-wise, because their stress chemicals are released into your water. And just like we release stress hormones in our body, they actually release it into the water. And they have cortisone just like we do for stress. And if that builds up, your fish gets stressed, their health gets bad. So these are all things to consider, that they evolved and that nature already worked on so hard for us. So, maybe go with the flow with nature a little bit is my personal view. But to each their own. What do you guys think? Let me know in the comments. I'd love to hear about it. Thank you so much for watching, and I will see you guys next time on the secret history and science living in your aquarium. And if you really want to support the channel, you can become a member for only $1.99 and get a bunch of extra episodes of audio-based format, all the news, all the academic research you can have your fill of right here on the secret history living in your aquarium. Great to see you guys. Have a wonderful day. Bye.